Is the next heading, beta. Friction on vertical surfaces. Friction on vertical surfaces. Okay. See here.
Yes.
This is your vertical surface. Say, for example, a wall, something like this. Okay. And there is a block which is being pressed against this one. Try to understand the logic of this one better. So this is a block which is being pressed against the wall. Now tell me, what are the forces you are acting on this one, beta? One is the weight of the body, no doubt in the mg in the downward direction. So the body is having tendency in the moving in the downward direction. So frictional force on this body will be acting in this direction, beta? Upward direction along the surface. This is your friction. Now tell me how it is actually being pressed along the wall when you apply the force on this one in this direction. So when you're applying the force in this direction, the normal will be exerted by whom, beta? The normal will be exerted by whom? The normal will be exerted by the wall in the opposite direction. So this will be the normal in the opposite direction. That is nothing but here. Is this point clear? Isn't
Yes.
it? So for your applied force here, capital F, there will be a normal because this is a surface in contact, beta. The surface in contact perpendicular to it will give the normal, but not the weight.
Yes.
Is that point clear? Isn't that is the only the logic you need to remember for all the vertical surfaces. What I'm doing right now here, let a block of mass em is pressed against a vertical wall. Against a vertical wall with horizontal force. With your horizontal force. How much, beta? Capital F. Okay. Capital F acts as shown in figure. Okay, na? See the first one. What is the normal force acting on this one? Normal force.
F.
Tell me. N is equals to your F.
F, yes.
N is equals to your F. Number 2. Limiting friction. Limiting friction. Limiting friction means the body is ready to start the motion, but it is not in motion, like static.
Yes.
FL is equal to your mu s into your N, and that is equals to mu s. This N is equals to how much, beta? Capital F.
Yes.
Isn't it? Once the body comes into the plane, once the body comes into the motion, then we try to take what type of a friction, beta? Kinetic friction. Then we'll try to take into the kinetic friction. So kinetic friction is Fk is equals to your mu k into N. This N is again equal to how much, beta? Mu k into your capital F. Is that point clear?
Yes.
So all the vertical forces problems, you can do it very easily right now for the given condition. Now see, when this body will be at the rest, beta, if your applied force is lesser than friction, then the body will be at the rest position, isn't it? So I'll write that condition that if your weight mg is less than your limiting friction, that means block is at your rest. Block is at rest. Block is at your rest. So therefore, friction will be equal to how much, beta? Friction is equal to your mg. Antena?
Yes.
Isn't it? It's in the same way, opposite case. If your mg is greater than, limiting friction, then what happens? Block slides down. So block will slides in the downward direction. That means at that time, what will be the friction, beta? Friction will be kinetic in nature, and that will be equal to mu k into your capital F. So what will be the relation? Can you tell me? As the body is moving the downward direction, force is mg in the downward direction, frictional force in the upward direction. So how do you write the equation right now here? Mg minus your Fk will be equal to mass into acceleration. So this will become for me mg minus, this is mu k into your, this one is nothing but equal to your applied force capital F is equals to m into your A in the downward direction, So this will be the given condition. The body is moving in which direction, beta? Downward direction. Is that clear?
Yes, sir.
This is only the concept which you need to remember in the vertical faces. Okay, na?
Actually, yesterday in college also we did this.
Okay, brother. So this applied force must be equal to normal. Okay?
Yes, sir.
We'll try to do one small problem. Find force P minimum shown in figure. Shown in figure. Let's say this is your vertical wall. And here is your horizontal block of weight of your mg. And here there is a static and as well as of your kinetic friction here, right? Minimum force acting on this one is in this direction, P minimum. Okay, and you are applying a force acting on this one is capital. Chalo, tell me, Ravga ji, try to do it out.
Sir, first of all, mg in the downward direction and normal
weight of this body in the downward direction. Friction will be in which direction?
Sir, upward, sir.
Mm-hmm.
Okay, there's movement upwards, so downward, sir.
See here, force P minimum, see in the figure, upward direction, you are applying the force of that one in the upward direction. So limiting friction, minimum
Friction
limiting friction. It will be FL because he has given μs and μk in the problem. So what we will take here? μs will try to take into consideration.
Yes, sir.
So P minimum enta avutundi cheppu. So P minimum is equals to your mg plus of your FL.
Plus.
Antena? So P minimum is equals to your mg plus FL is equals to how much better? FL is equals to mu into your n. What is n here? This is a normal, na?
F, sir.
Oh, yeah. Yes. So this will be equal to your what 8?
Yes, sir.
Chinda? One more question. Find force P. Find force P such that the block slides up with acceleration A. Okay, na? This is your vertical wall. And here there is a block right now of mass, yeah. And you are applying a force acting on this one, that is your F. So now what is this P? P is equals to your how much? Again, the friction between them is given as a for both mu S and it is also given as mu K. So now tell me, what is the force P?
Sir, the block slides up means friction is downward, sir.
Very good. What type of a friction?
Limiting, sir.
Yeah?
Sir, limiting.
Why limiting?
Okay, limiting it's moving, sir. Yes, sir. Kinetic.
Body move over mundu limiting.
Yes, sir.
When it is moving means it will be what? Kinetic, kada?
Kinetic, yes, sir.
And weight of the body is also in the mg. And acceleration of this block is in the upward direction, A. So how do you write the equation?
Sir, so how do you write the equation? A is equals to M.
Minus, this one is mg plus of your kinetic friction in the downward direction is equals to M into your A. Yeah.
Yes.
So P is equal to for me, M into your A plus your mg plus mu K into Fk is how much better? Fk is equals to mu into N. This N is nothing but equal to how much?
F, F, sir.
So mu K is mu into capital F. So it is mu into capital F. Which in the?
Yes, sir.
isn't it? So I hope now you got an idea how to do all the limiting problems. Only thing is you
Yes,
need to
sir.
take care of these forces. And this normal always acts perpendicular to the surface. Normal will always act
Yes,
perpendicular
sir.
to the surface part of relation. Take one more part of relation better. See this one. Let's say if a book is being held by the two hands and it is in equilibrium. Okay. Or else say for example, a block is being fixed between two vertical walls like this. This is one vertical wall here right now. And here there is another vertical wall. Okay. That means you are exerting the force on this wall is exerting the force on this block, but it is in under equilibrium. Under equilibrium. Under equilibrium. Equilibrium ante beta.
So from
The
two
weight of the
sides,
body is, yeah, there is no acceleration. Weight of the body is mg in the downward direction. This wall
yes,
is exerting the force on this direction.
force.
This wall is exerting the
So,
force on this one. Same walls kabatti, same
sir,
forces.
but now, which side shall we take the normal, sir?
That's what normal again. This will the wall is exerting the force on this one, and the block will exert the normal in the opposite direction. So the normal will
So
be in
two
this
sides
direction.
will have, sir.
Yeah, two side it will be having. This is also normal. And what will be the direction of the friction now? Can you tell me? The block is moving in the downward direction. There is one friction on this body in this direction. That is nothing but of your FL limiting. There is also one more friction on this one. That is FL. Two frictions will be acting. Two surfaces are in contact. Kada.
Yes.
Okay, now under equilibrium, what will write the
Yes.
condition? This mg must be equal to 2 times of limiting friction. Ante kada?
Yes, sir.
FL and FL are acting in the upward direction. FL plus
Yes,
FL
sir.
plus 2FL must be equal to weight. So that is a 2. FL is equals to mu into N. What is
2
N
into
beta
N.
here? Mg is equals
F,
to
sir.
2 into mu. N will be equal to your F. Clear?
Yes, sir.
I hope you got an idea. Okay, na?
Yes, sir.
So, I'll make one more application here. See, on the vertical wall, there is this block right now. Okay, this is a block of your mass here, and you are applying the force on this one in this direction. Okay, capital F. Okay, you are applying the force at a certain angle. The moment you see the forces at a certain angle, the first thing what you need to do is resolving it. Like this is given for me theta. Now resolve the forces right now bit. So this will become for me how much? F into cos theta in this direction. And in this direction, this will be your F into your sin theta. Now what are the other forces acting on this body beta? Can you tell me? What are the other forces acting on the body? No doubt the weight of the body acts in the downward direction.
mg.
Frictional force, if it is not in the motion, there will be frictional force in the upward direction. That is nothing but limiting.
FL, yes, sir.
Isn't it? And what will be the direction of normal beta? Direction of the normal will be in this direction. So this will be the normal acting on this ball. And what is the force acting on the wall by the force? This F cos theta. This normal is coming because of F cos theta, kada?
Yes, sir.
Because this F cos theta is only exerting the force on the block. Isn't it? This F is acting
Yes,
the
sir.
force in this
Yes.
direction. On the wall, it is your F cos theta. That means what is the normal here? Can you tell me? What will be the normal? This N is balancing this F cos theta. Isn't it? So the first
Yes,
point in
sir.
this one, N is equals to F into cos theta. When you're doing with
Cos
angles,
theta.
this is the way how do we need to do the problem. Got it?
Okay.
In the same way,
Yes, sir.
if your mg is greater than your limiting friction plus F into your sin theta, because F into sin theta is acting in this direction, upward direction. FL is also acting in the upward direction. Both of them are
Upward,
acting
yes,
in upward direction, kada?
Upward.
Kada?
Yes, sir.
That means these two are responsible for the balancing the weight of your mg. If your mg is
mg,
greater than
yes.
this one, then the body will slide. Ante kada?
Yes, sir.
If
Or
mg
else,
is greater
yes,
than
sir.
F sin theta and FL, then the body will slide. Then block slides. So friction will be kinetic in nature. Ante kada? As it is coming in the motion, so instead of your limiting, we'll try to take what? Fk. Isn't it? So it is moving in this direction
Yes, sir.
right now.
Because it's in motion.
Downward direction with an acceleration.
Downward. Yes.
So how do you write the equation
Yes,
right
sir.
now? So downward direction means this is your mg minus Fk is in which direction? Upward direction, plus F sine theta, upward direction, must be equal to mass into acceleration. Is it clear?
Yes, sir.
Is it clear? Isn't it?
Yes, sir.
So, point number 3. If your weight mg, if the weight mg is lesser than your limiting friction plus F sine theta, అప్పుడు ఏమైపోతుంది చూడు, your mg is
Sir,
lesser
will
than
stay
the
at
2,
rest.
isn't it? So the block will be at rest. So the block is at rest. The moment it is at rest means what will be the friction on this one? Friction will be balancing your mg. Anna?
Yes, sir.
So that is about your vertical forces. I hope you got a rough idea related to all the vertical concept right now. Friction on the vertical
Yes,
forces,
sir.
ఎలా తీసుకోవాలనేది క్లారిటీ వచ్చేసింది కదా.
Yes.
Next one, వెళ్దాం. Next one is about your motion of block. Motion of a block. Motion of a block on rough inclined plane. On rough inclined plane. On your rough inclined plane. So we're talking about your motion of your block on a rough inclined plane. The only basic idea in this one is we need to understand how to resolve it. Then that's it. Remaining everything will be automatically same. Like say this is your inclined plane beta. And this is your angle, that is nothing but theta. And here there is a block on Kundam. Okay. This is a block of your mass here. Okay. So what are you doing? So if the block, so we are talking about the motion of the body right now. There are two cases. If it is less, what happened? If it is greater than, what happened? Now tell me what are the forces acting first on this body? First is weight of the body. In which direction beta? Downward direction. That is nothing but no doubt mg. The next one is nothing but of your normal. This is nothing but of your normal. Now resolve the forces beta. If you resolve the forces, we are having the two forces right now here. Where do I take theta beta? This is theta. This is 90. This will be 90 minus theta. So this will become for me theta.
That is theta, yes. Sir.
Isn't it? This is theta. This is your 90. This angle is your 90 minus
90
theta. So obviously this total angle 90 aval kada. So obviously this is what for me theta.
Yes.
So this will become for me mg into your cos theta. And this will become for me mg into sin theta. So where will be the direction of friction beta? Friction will be in which direction? Opposite direction. So friction will be along this surface like this. So what is that?
Yes.
Limiting friction if it is at the rest condition.
Yes.
Isn't it? So this weight mg is always acting in which direction? Downward direction. So forces acting on the block are, can you tell me what are the forces acting on the block? Forces acting on the block. Forces acting on the block. First one is how much? Weight. Obviously, weight is always acting towards the center of the gravity or center of the earth. That is in the downward direction. The next one is normal. This normal n is equal to how much beta? This n is balancing your
mg cos theta.
Cos theta. So n is equals to your mg into your cos theta. Isn't it? Now third condition again. If your mg sin theta is lesser than your limiting friction. Is lesser than your limiting friction. That means this is lesser than mu into your n. That means mg sin theta is lesser than or equal to mu into n. N value is how much? Mg into your cos theta.
Cos theta.
Isn't it? That means it is above to slide. Isn't it? That means if it is right now given condition, if it is lesser than that one, if it is lesser than that one, so block is at your rest. Block is at your rest for less. Isn't it? So frictional force will be equal to how much at a time? Frictional force will be equal to FL. That will be equal to your mg sin theta. If okavela move avadam ledu ante. Anna kada. If your applied force is lesser than your mu mg cos theta, there is no chance of moving it out. So friction will be self-adjusting friction, gada. So it will be adjusting to the applied force. So FL will be equal to your mg into sine theta, because that is only the force which is trying to pull this body in the downward direction. But now this mg sine theta is lesser than of your limiting friction. So this will be adjusting with respect to this one. So what is the friction on this force? Ante mg sine theta. Clear?
Yes.
Now, if your mg sine theta, is equals to limiting friction FL, that means it is about to slide. It is about to slide. That means this will be your mg into your sine theta is equals to FL will be equal to mu into n. N is equals to how much better? Mg into your cos theta. This mg gets cancelled. So sine by cos will become for me tan. So this mu will be equal to how much better? Mu is equals to tan theta. Is it clear?
Yes.
Is it clear? Isn't it?
Yes.
So when the body is ready to move on inclined plane, means that is known as of angle of repose. Like theta is equals to alpha. Alpha is called as what better? It is called as of your angle of repose. Angle of your repose. That means the body is ready to move. That means if theta is lesser than alpha, the body is at your rest. Ante kada? If theta is equals to your alpha, then about to slide. About to slide. And if theta is greater than of your alpha, obviously the body will be sliding. That means whatever the angle we are taking, this theta, if this theta is equals to angle of repose, theta is equals to what is here? Alpha ankunam kada. That is known as a what? Angle of repose. Sir. If this theta is lesser than angle of repose, that means if this is very small, the body is at rest. Like say if this theta is 5 degrees, you have kept the block on this one. The block will never move. Now increasing this angle from 5 degrees to 10 degrees, 20 degrees, 30 degrees, 40, 60, 70, then this has a condition to slide down, Gada.
Yes, sir.
Isn't it? Because if you are increasing the angle, this is trying to tend to move in the downward direction. So that means if your theta is equal to your alpha, then it is ready to move. If your theta is greater than alpha, then the body will slide completely in the downward direction. So these are the three things you need to remember during the motion of the body on the rough inclined plane in the downward direction for that one. So what is the angle of repose beta? The angle at which the body is ready to move in the downward direction is called as of your angle of your repose part affiliation. Clear for everyone? Okay, na?
Yes, sir. Yes.
Sure. Next one. This one is fourth one. No, fifth point I'll write here. If mg sine theta, is greater than of your limiting friction, or I can say that this is theta is greater than of your alpha. Ante kada? Theta is what? Angle of inclination. Alpha is known as angle of repose. Theta is known as angle of inclination. Angle of inclination. And alpha is your angle of repose. The minimum angle at which the body is ready to move. Angle of repose. Ante minimum angle is దీని చూడు ఒక నిమిషం. The minimum angle like say is 30 degrees. 30 degrees unte right now it is ready to move. Okay na? If the angle is 15 degrees, it will never move.
Yes, sir.
అవునా కదా? Minimum angle is 30. దానికైనా పెరిగింది అనుకో, like if it is 40, 50, then the body will slide down. If your angle is like 29, 28, 30, it will never move. అవునా కదా? So if the angle is lesser than the angle of repose, it will never move. If the angle of inclination is greater than angle of repose, then the block will be moving. ఇక్కడ ఏం చేసుకొని చూడండి ఇప్పుడు. If mg sin theta is greater than FL, that means theta is greater than alpha. So obviously the block will slide down. అవునా కదా? So what is happening to this one beta? So block slides down. The block will be sliding down. That means frictional force will be equal to how much better at that time? F will be equal to your Fk, and that will be equal to how much for me? Mu k into your mg into your cos theta once it comes into the play. So what will be the acceleration at that time beta? Mg into your sin theta minus of your Fk will be equal to mass into acceleration. Avuna kada? So this will become for me how much right now? This one is your mg into your sin theta minus Fk. Fk is equal to how much for me? Mu k into n is equals to your mg into cos theta. So that will be equal to mass into acceleration. Everywhere mass gets cancelled. So obviously acceleration will come out for me how much for me? G into sine theta minus of your mu k into your cos theta. So this will be the acceleration down the incline. Okay. So what will be the force acting on that one? Net downward force acting on the block will be equal to how much beta? Net downward force will be net downward force on the block. Net downward force on the block. And then F is equals to your M into your A. That means that is equals to your M. A is nothing but G into sine theta minus mu k into your cos theta. And then, so this will be the force, isn't it? Now to prevent the sliding down, isn't it? Let's say sometimes you'll be asking the questions like this. Now to prevent it sliding down on inclined surface, this is your incline. So this is a block right now on this one, isn't it? This should be at the rest. What is the minimum force you need to apply on this one? What is this minimum force? This minimum force is equals to how much? What is the concept? So to prevent,
yes, sir.
To prevent sliding down, along the plane, the force needed is or the force parallel to it, you can write. The force parallel to the plane should be how much better? F minimum must be equal to, this is your mg into sine theta minus mu k into your cos theta. This should be the minimum force we should be applying parallel to the incline. And the incline ki parallel. This one is, say, for example, theta. Okay, na?
Yes.
Is it? So that is a given condition. Like say if I give you one problem on this one, say like this. This is your inclined plane. If this is your inclined plane and this one is your theta, which is fixed. Okay. And from here, the block is been coming down. This is your block of mass M, and starting from rest, U is equals to 0. Now it is coming to the lowest position somewhere here right now onto the ground. And this one is fixed on the ground beta. This one is fixed on the ground. Wedge has been fixed on the ground. It is not moving. Okay. So time taken to descend is how much? And velocity to come to the lowest position is how much? What is the velocity at this position? Okay. So the body is coming in which direction, beta? Downward direction, kada?
Downward direction, yes.
Isn't it? So friction is right now present here. As it is in the motion, here it will be obviously mu k. Isn't it? So now theta is right now fixed. This one is. So what will be the acceleration here? A is equals to G into your, this one is sine theta minus of your mu k into your cos theta. Initial velocity is 0 now. So distance traveled is, this is the length. This is the length of the inclined plane. So what is the distance it is traveling? L. So he's asking the time of descent is how much? Time of descent is how much? And with what velocity it is touching to the ground. So I can use the kinematic equation. S is equals to ut plus half into A into your t square. S value is how much better? Distance is traveling here right now. S is equals to your L. That is equals to 0 plus half into acceleration is how much for me? G into your sine theta minus of your mu k into your cos theta. Into your time. That is nothing but time of descent. That is d square. So the time of descent and the time of descent is equals to this 2L will go here right now. So this will become for me under root totally. So this one will become for me 2L divided by G. This one is G into your sine theta minus mu k into your cos theta. So this is your time of your descent. Time of your descent. Then what is the velocity when it is reaching to the bottom, beta? What is the velocity when it is reaching to the bottom? Isn't it? So what is the velocity? V is equals to how much? Velocity at the bottom will be equal to velocity at bottom. At bottom. How much beta? At the bottom of your plane will be equal to how much for me? V square minus U square is equals to 2as. So initial velocity is 0. So V is equals to 2 into G value is nothing but of your A value is G into sine theta minus of your mu k into your cos theta. The distance traveled is L. That means V value will become for me under root of your. This one is a 2g into sin theta minus of your mu k into your cos theta into your ear. So this is the velocity.
Yes.
Okay, now.
Yes.
So this is the way how do we calculate the velocity of the particle for the given condition. Vachinda?
Yes.
Isn't it? So these are the application. నేను ఏమేం చెప్పారు క్లాస్ లో?
Sir, in a vertical surface explain చేసి they did questions, sir. Duster book.
So I hope you got the idea. We already did one more time
Yes,
the
sir.
acceleration down the inclined plane and up the inclined plane. I think so.
Yes,
This
sir.
is down the
Yes,
inclined
sir.
plane.
Yes, sir.
Acceleration down the inclined plane formula ఏమవుతుంది చెప్పు సార్. Tell me acceleration down the inclined plane formula. Acceleration down the inclined plane is equals to how much for me? G into this will become for me sin theta plus mu k into cos theta. అంతే కదా?
Yes, sir.
If it is smooth surface, for smooth surface, this is down or up? This is up, na?
Yes, sir. Up.
This
up
one is your up because I have taken positive, na here. Down already yes, we got negative. Acceleration to go up is g into sin theta plus mu k into cos theta. For smooth surfaces, mu value will be equal to 0. So acceleration up or acceleration down for the smooth surfaces will always be equal to how much for me? G into your sin theta. Yes, so this will be your G.
We did this on 10th, right?
Is better?
Tuesday. We did this on I guess yeah. We did this on our last class, like last week.
Last week le eppado chesinattunnanu. Avunu kada. Ee week syllabus em undu?
Sir, ee week vertical surface
and as well as of your motion kada.
Inclined, yes, sir. Block and block, vertical surface and inclined. Yes. Okay. The three on that.
Okay, fine. I'm restarting it once again. Better you join it out. Time ఉంది కదా మన దగ్గర.
Yes, sir. ఇంకా 12 minutes.
10-20 minutes ఉంది. ఒక చిన్న కాన్సెప్ట్ ఉంది, అది కూడా చేసేసుకుందాం మనం. ఓకేనా?
ఓకే. yes.
దేనికి వస్తుంది అది?
సార్ ఇది ఇంకా ఈ మీటింగ్ ఇంకా 4 minutes ఉంది సార్. ఈ మీటింగ్ అయిన తర్వాత
అదే 4 minutes ఉంది. 4 minutes లో నేను ఏం చేయలేను కదా అని.
ఓకే సరే.
I'll end it and I'll rejoin.